guys. So this is second day that I'm learning Shesar. I'm trying to port my Conway's Game of Life simulation from Golang to C#. So yeah. So let's just go to what we have here. Alright, so where's my bookmarks? Where are my bookmarks? Pattern matching, okay. So I was here. So last time we actually reached out to pattern matching in our tutorial section, documentation section. So yeah, so and I left over here, I think. Yeah. So we stopped recording the session right here, so we'll continue with it now. So let us just open tmux and then let's just do like this, right? Alright, so wait a minute, x must be assigned. Okay, yeah. So we were exploring the out, this out, I don't know what we call this. What is this out thingy? What do you call this out keyword? Okay, this is a keyword, right? What is a keyword? Keyword in... What does this mean actually? So keyword are the okay. So keywords are the set of a set of words that have an inherent meaning in the language, that and you cannot create your own thing out of it because they are baked into the runtime or baked into the language itself. So yeah, okay, makes sense. Alright, so for enum matches, another common use for pattern matching is to match on the values of enum type. This next sample processes the input records to create a tuple where the first value is an enum value that notes a deposit or withdrawal. The second value is the value of the transactions. Okay, so we have these records, right, which has the action, the value, and the remarks, let's say. And then you can also define a string with these three double quotes. Okay, and we have this entry point, we have our current balance for each transaction in transaction records of bank records. So what does this mean? Transaction records. So transaction records, this takes an input text, right? This takes an input text and of type transaction type. What is transaction type? Transaction type. Okay, so this is an enum with a deposit, withdrawal, and invalid, right? Okay, so I in static enumerable, and this takes a transaction type and double amount. Okay, the preceding example also uses an exhaustive message. Okay, so what does this mean? What is enumerable? This is a type, right? So this whole is a type that this function returns. So this transaction record returns an enumerable of transaction type and then double the amount. Transaction type has these enums. Oh, okay. And this can be enumerated. That is like it can be, this is like you can go through each of them in a step. So that is what enumerable means, right? Anyway, so just to be sure, let's just ask ChatGPT enumere. Okay. The interface in C# that represents a sequence of elements that can be iterated over one at a time. Exactly. Okay, so it is a part of the system that collections such generic namespace. It lists you use for each. Okay, so we are using for each var. Okay. So let's just try to replicate what we have in here, right? Public static class example program. Okay, so let's just try to replicate what we have in here. Class program, and then public static void sta void main, and this is our main function. And then if this is our main function, then what we can do is we can do static enumerable of this, and this is a function name and function name, right? And this takes like a text of string, and this just returns a tuple, right? So this returns transaction type. So enum okay, so enum is okay, public enum. Okay, this enum type is public, and this is our transaction type, right? And we have certain fields over here. Constant and records. Okay, so this is our transaction over here, and then what is this, like what? Why is this not a string? Do I need to do this? No. Is this going to, okay, anyway, so we have three enums, right? Deposit withdrawal, okay. So deposit withdrawal. So we have two enums, right? So this is how we define enums. Okay, deposit and withdrawal. Okay, now what I want this, so this function, this actually, so this returns a tuple of transaction type and double, right? So this returns this. Is that correct? Transaction type and then double the amount. Why do you even need this identifier over here? Shouldn't this just be type? Oh, okay. So enumerable generics. So I need to first learn about generics in C# before I understand this. Is that correct? Okay, so let's just do generics and any data type. What is type safety? Okay, dictionary enumerable of type D tasks, get first D, list D items, public static of type D, and get first will use this type, and then return. Okay, so this expects a list of this type, and with variable this you can okay, but I want to ask what what this means. Explain this. This is the return type declaration of C# method. Yeah, I know that. It belongs to the enumerable. This means the method returns an enumerable transaction type D. This is a tuple with two elements. Okay, so this returns a tuple, right? But how can you access the value within the tuple, because you did not define the fields that contain those values? So these are the fields that this function returns. I'm sorry about that. so this actually this is a type, and this is the accessors that this function returns, right? So this is a type paragraph, right? And this is like the amount or something like that. Okay. What are they even doing? What the? Anyways, this is a shit show, man. What? Come on. Alright, so for this, okay, so we are, okay, so let me just understand what is happening here. Why is this not a string, man? Why is this not a string? Void public static void main for each. Okay, so maybe because it is defined over there. Yeah, no, this is something's wrong with it, man. Anyway, so double, and I have this amount is 0.0, right? And then for each, and then we have a variable amount for each amount in, you know, transactions. For each amount in transactions, so I cannot do this, and this is not enumerable, so I have to wrap it in as a transaction of type, you know, transactions, and this returns enumerable. Okay, for each, if a dot, so how is this like a dot type? Okay, so this actually, this returns a is a tuple, right? So yeah, this is enumerable in tuple, so I can do something like this. If a dot type, yeah, let's just go lang fatigue. If a dot type is, can I do this on the right? Yeah, transaction type dot deposit, then I can do something like amount plus is equals to a dot amount, right? Yep. Okay, and now else if a dot type equals type dot deposit, and then what do I have here? Withdrawal. If a dot type is transaction type dot withdrawal, we can do something like amount minus is equal to a dot amount. Alright, withdrawal, and they also had this invalid, right? So okay, but invalid is not even like used anywhere, or is it? Oh, okay, so that's like something we can do later on. Now console dot write line remaining is, okay, so you have to do something like this. Right, yeah, so total amount remaining is this. Okay, now what I can do is basically I have to yield an enumerated value out of this transaction, right? So for that, how does that work? So we create a new string reader which like takes the whole of this text, and then according to some sort of logic, it reads every line. So the string line, while line is okay, so you are actually like inlining this statement and creating a new variable right here. Okay, so reader.readline will read a line, and this will assign it to this variable, and this just like inline checks if it's null or not. If this is not null, that is, if it is null, then readline actually returns null if the next line is, if the text is over, right? So okay, and then we split it out of commas, and then we decide on the type, and we decide on the value, right? Yield return, and yield will actually return the enumerated value. Okay, makes sense. Okay, so we will create a reader, right? So reader is a string reader. How okay, so new string reader. Okay, so string reader is within the system namespace, and then we provide it with the t, new string reader of t, and then now we have this variable called string nullable string, but yeah, okay, nullable string, and we have this line. And then now what we can do is we will, while there is a line, we do this, right? While there is a line, we do this. While there is not a line, then we yield while there is a line, we yield until something is there, right? Okay, and we have that value within line, right? So we can actually do something like line is equal to reader dot read line, and if the line is not equals to null, if this is not equals to null, okay, read line, if this is not equals to null, we move forward. Now for split it, for everything within each line, we have 3 items, right? So first we have this array of string, right? So how do you define array of string? Okay, string same as Golang, but you have this in Golang. So yeah, okay. Anyways, so string array splitted is equal to line dot split. Split is like this. Split is like this. Now we have the action splitted 0 dot to upper trim dot to upper. Okay, action is this, and now the amount is like, that is still a string, right? So string amount is equal to splitted 1 dot trim dot. Okay, so this is the amount, and then we have our remarks, and we don't need that remarks here. So okay, if action equals deposit, if action equals deposit, then like yield, isn't that correct? yield, right? Why is this not a keyword here? What if action is deposit? If action is deposit, then yield this tuple, right? Okay, so yield this tuple on transaction.deposit comma action dot value. So how do I convert it into an integer. How do I do that? Return an amount. I know how. What is this amount part? So we have this parts, right? And then transaction type is this. Double the try parse this and out double amount. Okay, yeah, we went through this. Yeah. Okay. So if yield transaction title 0.0 invalid, we have invalid in here, and then we have invalid in here, and we can do something like double dot try parse, right? Double dot try parse, and then this will take the amount, and this will take like the out variable, out double of type, a or something like that. Yeah, right. Okay, yeah, amount. Okay, if double the try parse this double the amount. Okay, this makes sense. And then while is over here, this is the while loop. Okay, what is this? Okay, we have this over here, and we yield. When do we yield, man? So this is the while loop, right? So, and this is the if statements closing bracket. Okay, else we yield transaction type dot withdrawal of type. This has a in here, this has a in here, and then else if action is withdrawal, we yield this, right? Yep. Okay, yield. Okay, so yield will. Okay, yield return is a keyword, right? What is this yield return? That lets a method return a value one at a time instead of all at once. It is used with methods that return IEnumerable or IEnumerator. Okay, so when to use yield return? You want to generate items lazily on demand. You don't want to build and return a full list upfront. You're streaming data or processing large data sets line by line. Okay, so when the caller for var for each will use IEnumerable, and it will like invoke this function every time until it returns nothing, right? Okay, makes sense. So console write my number, var number is get even numbers. This actually invokes this function, and actually this IEnumerable maintains its own state, right? So for example, there is one invocation here, and it actually updates the state, and it the yield return will like return the value and pause the state of the function. So the state of I is preserved until it is invoked next. Okay, that makes sense. That is pretty cool. I haven't like used yield anywhere. Like I know you can use it in C or or C++, or yeah, even I don't think you have enumerator on Golang, or do you? I don't know. Anyways, so yeah, okay, so yield is not a keyword, but yield return is. Okay, alright, so this returns what I want to return, And okay, let's just build and run this if this runs or not. Okay, expected this in 36. Where is 36? Okay, we need this in here. Identifier expected 39. In 39, identifier expected. What do you mean identifier expected? What? Syntax error. Error on 39. Where is syntax error, man? What? Where's the syntax error? There is no syntax error. It's not null. Is not null. Is not okay. Is not null. What? Where do you have syntax error on 39? It's static. This is a static IEnumerable, and this takes this type tuple. This returns this type of tuple and transaction. Okay, wait a minute. Transactions. Okay. Transaction, and this takes a. Wait a minute. Okay. Again, Golang fatigue. String of type text. Okay, so type namespace IEnumerable could not be found. Okay, so where is this IEnumerable located? If you're missing a directory or an assembly reference. Okay, IEnumerable, ENUMERABLE, ENUMERABLE, IENUMERABLE. Public static void main static IEnumerable transaction request. What? This is in 39, right? Public class program, public. Okay, wait a minute. I need to define it, but I can't define it here, right? Missing partial modifier declaration of partial modifier. What does this mean? Okay, so now program consists of this text. The type or namespace IEnumerable could not be found. What do you mean? What do you mean? IEnumerable. Isn't IEnumerable within system class, or IEnumerable is the base interface, public interface, IEnumerable, system.collections. This is in system.collections, right? So do I need to use like using static? Do I need to do this? Sorry. Using static rate can come up to apply to types and it's a namespace, not a type. Okay. Using system.collections. IEnumerable cannot be used with type arguments. The non-generic type cannot be used with type arguments. What? What's wrong with it, man? Using system.collections. IEnumerator, IEnumerable.get enumerator. Okay. Wait a minute. IEnumerable. No, IEnumerable. Static IEnumerable. This is a type, right? Why is this not working? System.collections.generic. System.collections.generic. Okay. Using system system.generic. Okay. Dereference of possibly null reference. Am I disabling? Okay, this is a nullable, right? Implicit usings disable. Okay, this is all good. Type or namespace string reader could not be found. Is this why we use like, you know, Visual Studio, because it warns you about this thing? But this is the same thing, like you are getting errors either in the IDE or when you build stuff. It's just convenient when you have that IDE so that you can fix it before you build stuff. But yeah, we are just learning, so it's okay. The type or namespace name string reader could not be found. What does this mean? Let's just go through here. The type or namespace IEnumerable could not be found. Are you missing or using directive or assembly? IEnumerable. To use IEnumerable, what do I need? What do I need? Why do I need it? Link you. Enumerable. IEnumerable. Public interface IEnumerable out system.collections.IEnumerable exposes the enumerator which supports simple iteration over collection of specified type. Okay, type parameters. This is using system.io, system.collections. System.collection is a generic stream reader enumerable. Where is this yielding stuff? Where is this yielding stuff? There is no yields in there. Okay, so is this not the correct program? Static IEnumerable of this type. Okay, so I don't know how to use this, right? Let's just paste it to ChatGPT and ask if it knows anything. System collections generic. If I use this, yeah, I actually using system collections generic, right? And then we have this system collections generic div and says string type name string reader, but it breaks a string reader. Why does it break a string reader? Using system.io. Okay. Okay. So string reader is from system.io. Does this mean this will work as well? It will not, because console is from the system namespace. Okay, the console is from the system namespace, right? And we are like, you know, so using system, like using this will expose everything recursively. If it exposes everything recursively, if it exposes recursively, yeah, okay, so we can use string reader because it is within the IO namespace, right? So we can do something like io.string reader, io.string reader, right? Can we do this? Can we do this? No, it can't be found. Okay, so system.io. Okay, so using system.io, we can do something like that. Okay, we can do something. Okay, wow, what is happening here? So I have like string reader is from within the IO namespace, and like you can use string reader if we do this, right? Wait a minute, this is not true, because string reader is from IO and we haven't imported IO. Oh, okay, so it breaks even before it gets here. So okay, I got it. Okay, got it. String varies from I namespace. Okay, this makes sense. Finally. Let's just run it and see if it worked or not. Wow, why is it taking so long? Anyways, type patterns, deposit, public record deposit. To finish this tutorial, let's explore one more building block to pattern matching, the type pattern. The type pattern tests an expression at one time to see if it's the specified type. You can use the type test with either an is expression or a switch expression. Let's modify the current sample in two ways. First, instead of a tuple, let's build deposit and withdrawal records types that represent the transaction. Add the following declaration at the bottom of the interactive window. And we're not using this, so public record deposit. Okay, this is of type tuple, but this is of type record. It's not a tuple, it's of type record. So deposit has amount and description, withdrawal has an amount and description. Public static enumerable will return an object, or it could be null, and transaction record type will take this input text. If it is string variable, we have lines, we assign the line to a line variable, we split it, we do this, and we try to parse it to amount. And if the transaction type, the two upper is deposit, this. Okay, fine. Replace the for each loop in the main method with the following code. Okay, so for each variable, transaction record type, this is what we saw earlier. Current balance plus is transaction dot. Okay, this is what is new here. So transaction, wait a minute, what is this? Like transaction, we take transaction variable for switch, and if the transaction is of type deposit, okay, if the transaction is of type deposit, we return the amount, right, and we plus it. Okay, but if it's of type withdrawal, we return the negative amount, so that it becomes like it reduces the current balance. Okay, if it's of type anything else, we turn 0. Okay, this is cool. Okay, type patterns to type pattern. Okay, exhaustive matches with switch. Okay, we skip this. A series of if statements can turn a series of conditions, can test a series of conditions, but the compiler can't tell if a series of if statements are exhaustive or if later if conditions are subsumed by earlier conditions. The switch expression ensures both of those characteristics are met, which results in fewer bugs in your apps. Let's try it and experiment, cover them all. Okay, so current balance is transaction. So when you run the code, you see that it works the same. To demonstrate some subsumption, reorder the switch arms as shown in the following statements. Transaction type to deposit. Okay, run with the compiler issues an error because the arm this matches every value. As a result, the final AMO transaction withdrawal never runs. Okay, so this is for safety reasons. Okay, makes sense. Okay, let's just try to replicate it if we understand it correctly. So we have like two types, right? Public record of type deposit that takes a transaction type transaction type action, and then double amount, right? And then we have withdrawal of type action, transaction type of type action, and then we have like double the amount, and we don't need this. We only need this, right? So transaction type, is that correct? Double the amount of string is to description. So okay, only need this. We're in the right track. So now what we can do is we can use this like switch statement, right? So amount is this, we do something in here. So for each bar transaction, we do something like amount plus equals to A, switch over this, and we could do something like deposit D, and we return deposit. If it's a deposit, we return D dot amount, right? And if it is like, if it's a withdrawal, return minus W dot amount, right? If it's anything else, we return 0.0. Okay, okay. And now what do we do here? Wait a minute, let's just save it for now, because I think we need another snippet that I deleted accidentally. Okay, so yep, public record deposit, we don't need this. Okay, now what we can do is we can replace this with this, right? Yep, and then we can do something like, we just return something here. We return withdrawal of amount this, return deposit of amount this. Can we do this? Is this correct? Yep. Yield return new. Okay, this is also like, this is a record and we need to instantiate it, right? So to instantiate something, either it's a class, struct, or even a record, we need a new keyword. And yield return will return one at a time. Okay, and we return something like 0.0. And what do we return in here? Okay, this also returns null. So transaction type, this returns transaction type, right? This will return an object actually. So we have object, and this could be null, because if this is not deposit or withdrawal, nothing gets returned, so this is null. And we can we can return anything, and to signify that we use this object, and for nullability we use this question mark. Okay, that makes sense. And now is this okay? Okay, I think this should work. Okay, this expected in where? 33. Okay, do we need commas here? What? We need commas? Okay. Transactions. Okay, this is like something different than I thought. The syntax is completely different, because this is a statement. Switch to this. Okay, take this and switch to this. This will actually return, this is actually like a function, right? This is like an anonymous function. It is not actually, but this acts like it. Okay, so the switch statement takes and can put A, and it goes through this exhaustive list from top to bottom, and checks the type of A, and if it is of type deposit, this will just return this and not go through here. Okay, this is something different than I've seen other languages do. Okay, 192, yeah, this is the same. 19250, yeah, this is the same. Okay, type patterns. Okay, alright, so we even finished this C# language strategy. How strategy guys, the strategy guys are decision C# narrations. The C# community continues to grow. The language continues to evolve to meet the community's needs and expectations. We draw inspiration from many sources to select features. Okay, developers in .NET front and back end. Okay, learn C# for Java developers. Fundamentals, program structure. Okay, Now this is actually where we start tinkering on architecture and understanding the design patterns or the design decisions of C#, okay, and the structure of C# project or .NET projects. Okay. Alright, so namespace C# programs consist of, maybe I should have started with this before I went through this, because now I think this section will describe this, namespaces, classes, and the entry points and all of that. Anyway, so C# program consists of one or more files. Each file contains zero or more namespaces. Okay, our namespace contains types such as classes, structs, interfaces, enumerations, delegates, and other namespaces. The following example is the skeleton of C# program that contains all of these elements. Okay. Hello world, this is in global scope, right? And we define a namespace, and now we cannot define anything below this in a global namespace, and C# will not execute that. Okay, so we have this namespace and we have our class, some independent class, and we have a struct, and we have our interface, and we have a delegate. I don't know what this means yet. And we have our enums, and we have our namespace, nested namespace, and we have some sort of struct. And there is no entry point here, and this is the only entry point. Okay. The preceding example uses top level statements for the program's entry point. Only one file can have top level statements. Okay, so only one file can have top level statements. Okay. The program's entry point is the first line of program text in that file. In this case, it's the console.writeline hello world. You can also create a static method named main as the program's entry point, as shown in the following example. Okay, we import some sort of namespace, a defined namespace, and then we have our namespace, we have our class, we have our struct, right? We have our struct, we have our class, we have our struct, we have our interface, we have our delegate, we have our enum, nested namespace, and we have our class program, and we have this entry point here. Okay. You can also create a static method called named as the program's entry point. Okay, so can I do something like this? Like, this is buildable, right? Yeah, but can I do something like this? The entry point of the program is the global code. Ignoring program.main string empty. Okay, wait. Hello world from global namespace. Hello world from global. Okay. The entry point of the program is the global code. Ignoring the program.main string entry point. Okay, so there can only be one entry point, and the .NET runtime will ignore this entry point because this takes more priority. This takes more priority than the names scoped entry point. Okay, but can I do something like this? Can I do something like this? Hello world 2. What does this mean? Okay, wait a minute. Your namespace 2, your struct 2, your wait, I need to do this. Okay, so program has more than one entry point defined. Compile with /main to specify the type that contains the entry point. What does this mean? Program has one more. Compile with /main. Let's just ask it because it has more context, and we don't need to search. Ensure you have only one. Remove the comment out the extra main methods. Compile with /main option if needed. CSC C# compiler /main is program your file.cs in the program class. Okay. What? In program class? CSC. I do not have CSC. CSC Linux chicken CSC chicken compiler for C compiler. What? You don't need a specific ID to index or working with C# development ID is okay. Let's just not go through this rabbit hole right now. Grep static void main. Okay, static void main. Yeah, this is one way to find if we have multiple entry points or not. Visual Studio build checks.cs project and file structured into only one program.cs file, and including the templates program receive the top level statement is okay. I cannot have more than one endpoint, and this will throw an error. Good to know. Main method, the main and command line arguments. So this we have this arguments, we have this like string, and then the following example is for reason display the command line arguments. Yeah. String builder is new. System to text builder.append line, following arguments passed for each value args builder.append line, this console builder.toString. Yeah, okay. But what is this? Like, okay, so does this mean can I do something like this? I have this, right? And this one's fine, and I am actually worried. Okay, can I do something like string reader is new of this? Can I do something like this? Yeah, okay. If I like specify the type already, I don't need to like do new and then the struct or the type or the object, right? So can I do something like deposit if this is this? Okay, return new deposit. Okay, so can I do something like this? Deposit dt is new 10 and console dot write line deposit is this dd, right? Can I just wait a minute, can I do something like this? Nice. Okay, I got it. Either I have to do this or I have to like specify the object during like a new object and instantiate it, deposit, and I can do something like var so that it automatically infers the type from the instantiated object, right? Okay, yeah, that makes sense. Okay, that makes sense. Static void main static in the following English shows the most common main declarations. The main method is the entry point inside a class or a struct. The enclosing class can be static. Main must be static. Main can have any access modifier except file. What do you mean access modifier? Access modifiers. All types and type members have an accessibility. If the accessibility level controls whether they can be used from other code in your assembly or other assemblies. An assembly is a DLL or exe created by compiling one or more CS files in a single compilation. Okay, public. Okay, access modifiers. Okay, got it. Access modifiers. They represent if your class or struct is publicly, privately protected, in a protected mode, accessible or not, right? So that means static main can have any access modifier except file file. Okay, main can either have void int task or task int return type. Static asynchronous task main, static async task that returns an integer. Static async task main, static async task int main, string args. Yeah, okay. Main return values. Args, no use of await, no use of await, no use of args or await. Static async task main, no use of args, uses await. Static async task int main string args. Okay. If the return value for main is not used, returning void or task allows for slightly simple code. Static void main, static void is the async task main. Now, by returning integer or task int enables the program to communicate status information to other programs or scripts that invoke the executable task. Oh, okay. If the main method returns something, then that is like the exit code for Linux, or something like you know, so we can do something like this, where we have main method here, static public void, let's just return an integer and then return 1. If we do this, wait a minute, what did it, okay, wait a minute, sorry about that. If we do something like this, then echo this is 1, right? But if we do something like 12, and then okay, yeah, got it. What if I don't return anything? Okay, return 0. Alright, main method. Next create a partial script to run the application, display the result. Yeah, right, this is what we did. But in Linux, async main return value, when you declare an async return value, main compile generates boilerplate code for calling asynchronous methods in main. If you don't specify async keyword, you need to write that code yourself. I show in the following example class, async main return value test. Okay, public static int main return async console work dot get awaited dot get result. Private static asynchronous task async console work, right? This is the async function, and this returns, this is boilerplate work, really. Static async task integer is done async console work, static async task, private static async, this is the return value, right? This is the return value, static async task. This is an asynchronous function. This is a promise that returns type integer, okay? And this is an asynchronous, this is a promise that returns integer. So yeah, this is the same type, right? But to get this type, I have to use, like, this returns a task, right? So I get the task and I wait for it to complete, and I get the result or the return value from that awaited function. So this is the same. This is same like the TypeScript's you know, awaited return type of some sort of function. This is the same like this, right? Yeah. Got it. Static void, static async task main. Okay. Main methods, top level statements. Okay, long dot parse. Okay, following the command arguments in the console arguments, I know how to do that. Okay, fine. Now, top level statement programs without main methods. This is what we stumbled upon yesterday, and oh god, I should have read this before I went through like the get started section yesterday. Yeah. Okay, so you don't have explicitly okay, so I'm just checking if there's some updates or not. Okay, it's fine. Alright, I actually signed up for a swimming class, and I need to go and buy some, you know, accessories like the glasses and maybe a swimsuit. Maybe I don't need a swimsuit. Who needs a swimsuit? I just need a glass pair, not even a pair. I just need glass swimming glasses. So yeah, Anyways, exciting times. I will be quite busy from tomorrow because I will wake up at 6 and then eat and then go for swimming at 6:30 up until 8, and then I have to go to work from like after 8. I have to go to work from 9 to 6, and then I will come back and then go to gym and then just eat and then just sleep. So this is going to be pretty hectic from tomorrow. I also have to go to this anyway, so I don't want to say that. So okay, let's move ahead. Only one top level file. An application must have only one entry point. A project can have only one file with top level statements. Putting top level statements in more than one file improves the result of the following: compile only one compilation unit and no other entry points. You can write a main method explicitly, but it can't function as an entry point. The compiler issues the following warning: the entry point of the program is a global code ignoring main. Right, this is what happened when we tried that earlier. Using directives. If you include using directive, they must come first in the file as in the example. Yeah, makes sense. Global namespace. Top level statements are implicitly in the global namespace. Namespace and type definitions. A file with top level statements can also contain namespaces and type definition, but they must come after the top level statements. For example, we can do this, right? Namespace, my class dot my method, my class dot test method. Okay. Args. Top level statements can reference the args variables to access any command line arguments that were entered. The args variable is never null, but its length is 0 if no command line arguments were provided. For example, okay, since args are just strings, they are array of strings. Okay, so I don't know arguments for each for args and args. Yep. You can call an async method by using await. Okay, on like top level as a top level statement. Okay, exit code for the process, return value as you would in. Okay, you can just return value from like top as a top level statement. Okay, and that just returns that value out of the program to the caller. So implicit entry point method. The compiler generates a method to serve as a program's entry point for a project with top level statements. The signature of the method depends on whether the top level statements can contain await keyword or the return. The compiler generates a method to serve as a program's entry point for a project with top level statements. Okay, so it fills with boilerplate before it executes the top level statements. The signature of the method depends on whether the top level statements contains the await keyword or the return statement. Okay, the following table shows what method signature would look like using the method name main in table for convenience. Await and return. If there is an await and return in top level contains, then it will encapsulate in some sort of static async task int main, right? Some sort of like this a task, or this would be even like t or something. Is it okay? So let's just do something like this. Let's just do something like this, right? Return 1. This is runnable. Return 1. This is runnable or not? I don't know. Can you return? Okay, yeah. Cannot implicitly convert type string into int. Okay, yeah, got it. Okay, so only integer values are returnable from global namespace or the top level statements. Okay, so that means it's easier. It's only integer. The boilerplate will only contain like integer values. If it's contain returns, or if it contain await static async task main. Async task main will top level code contains await. If it contains await, the top level statements will be encapsulated to static async task main. Okay, if there's a return static in main, no return static void main. Okay, all right, we went to this as well. Type system overview: namespaces, classes, records, interfaces, generics, and anonymous types. anonymous types. Okay, so let's just go through the type system. She's our type system, strongly typed. Yeah, specifying the types and variable declarations. How much time has it been? Okay, it's been 1 hour, so let me just take a break and I will come back to this state after I feel like it. Okay, yeah, see you guys.